Hello everyone, this is Vahita from CSE Department of Rohini College of Engineering and Technology. I'm going to explain a few topics of the subject CS 3352 Foundations of Data Science. In this video, we are going to discuss the topic about normal distributions and standards scores. So first let us see about the normal curve. The normal distribution is a continuous probability distribution that is symmetrical on both sides of the mean. So the right side of the center is a mirror image of the left side. So we have some properties for the normal curve. The normal curve is a theoretical curve defined for a continuous variable and noted for its symmetrical bell-shaped form. Because the normal curve is symmetrical, its lower half is a mirror image of the upper half. The normal curve peaks above a point midway along the horizontal spread and then tapers off gradually in either direction from the peak. The values of the mean, median, and mode located at a point midway along the horizontal spread are the same for the normal curve. Now let us see about the properties of a normal distribution. The mean, median, and mode are all equal. The curve is symmetric at the center. Exactly half of the values are to the left of the center and exactly half of the values are to the right. The total area under the curve is 1. So that is shown in the figure. Now let us see about different normal curves. It is instructive to note that the various types of normal curves that are produced by an arbitrary change in the value of either the mean or the standard deviation. It is shown by the symbols shown in the bracket. Obviously, the differences in appearance among the normal curves are less important than we might suspect. So because of their common mathematical origin, every normal curve can be interpreted in exactly the same way once any distance from the mean is expressed in standard deviation units. Z-scores. A Z-score is a unit-free standardized score that, regardless of the original units of measurement, indicates how many the standard deviations a score is above or below the median of its distribution. So it is depicted by Z is equal to x minus mu by the standard deviation symbol. So SS score can be defined as a measure of the number of standard deviations by which a score is below or above the mean of the distribution. In other words, it is used to determine the distance of a score from the mean. If the Z-score is positive, it indicates the score it is above the mean. If it is negative, then the score will be below the mean. However, if the Z-score is 0, it denotes that the data point is the same as the mean. To obtain the Z-score, express any original score whether measured in inches, milliseconds, dollars or IQ points etc. as a deviation from its mean and then split its deviation into the standard deviation units, where x is the original score and mu and standard deviation are the mean and the deviation for the normal distribution of the original scores. Since the identical units of the measurement appear in both the numerator and denominator of the ratio for Z, the original units of the measurement cancel with each other and Z-score emerges as a unit-free or standardized number, often referred to as the standard score. The Z-score consists of 2 points. A positive or negative sign indicating whether it's above or below the mean, and a number indicating the size of its deviation from the mean in standard deviation units. Now let us see about the standard normal curve. If the original distribution approximates the normal curve, then the shift to standard or the Z-scores will always produce a new distribution that approximates the standard normal curve. So this is the one normal curve for which a table is actually available. So although there is an infinite number of different normal curves, each with its own mean and standard deviation, there is only one standard normal curve with a mean of 0 and a standard deviation of 1. So this is the formula for that. Mean is equal to 0 means we have mean of Z is equal to, this is the formula, and standard deviation is equal to 1 means we will be substituting like this. Using the top legend of the table, notice that the columns are arranged in sets of 3 designated as A, B and C, and the legend at the top of this table. When using the top legend, all the entries refer to the upper half of the standard normal curve, and the entries in column A are the z-scores beginning with 0.00 and ending with 4.00. And using the bottom legend of the table, the columns are designated as A, B and C in the legend at the bottom of the table. When using this bottom legend, all the entries refer to the lower half of the standard normal curve. A negative z-score columns B and C indicate how the z-score splits the lower half of the normal curve. As suggested by the shading in the bottom legend of the table, the column B indicates the proportion of area between the mean and the negative z-score, and column C indicates the proportion of area beyond the negative z-score in the lower tail of the standard normal curve. Finding proportions. Finding proportions for one score. Sketch a normal curve and then shade it in the target area. Plan your solution according to the normal table. Convert x to z, which is shown in the first figure. And finding proportions between the two scores, sketch a normal curve and shade it in the target area, finding the proportions which is between 245 to 255. Now plan your solution according to the normal table and convert the x to z by expressing 255 as shown in the figure. So this is a diagram which shows that. Thank you.